Yeah. So last time we started talking about the statistics part. We are done with the probability part. So, and we started talking about the population of we have a difference between the probability theory and the statistics part of the statistics is that in probability theory we assume that we know the PDF or the distribution of the population. However, in practice, we don't know the PDF, or we don't know the mean, we don't know anything about the population. We need to estimate this so that other people can work down problems assuming these PDFs. So in order to be able to estimate the average of the population, the average age of people, or the average height of students in certain school or whatever, if you don't have access to the population, you need to do something. You need to find a specific sample and calculate, try to find this average variance in the whole video. And what we are trying to discuss here is what are the different ways to do this estimation. Okay? So as I mentioned, it's the opposite way of looking at problem. So we define the population, which is the whole everything basically that contains everybody. And we define the sample, which is a subset of population, and then we talk about variables and different examples of that, and so on and so forth. And then we try to clarify this, as I mentioned. In probability, we assume that we know everything about PA, so we give you the PA, and we actually find the probability that a specific person in Saudi Arabia is height or tall, is taller than her, or the least than her. Assume certain PA. Here, no, we assume in this part of in the potential statistics, we don't know the population. What we are trying to do is to collect a sample and try to estimate some of these parameters. So we started with the sample mean. So if we have a sample of n samples, then we know from high school and others that the sample mean is basically summing all the samples divided by n, right? And the population mean is x bar, which is expected value x. And this is basically the parameter that we don't know, that we are trying to estimate using certain samples. Right? And in order to find the sample, for example, if for a data set, we don't for the population variance that we don't know, we need to estimate the sample, the variance from the sample variance. And the way we do it using this equation. So in general, you would ask why are we dividing by n over 2, n minus 1? That's why we talk about it. This is to provide the to satisfy one of the properties of the estimate. So in general, we start with the point estimator or the current point estimation. There are three different types of estimation, as I mentioned. Point estimation, we discussed here, and interval estimation, where basically you estimate with certain probability that the estimator is within the correct, the true value is within this period or interval. And the last one is the hypothesis. We try to move as much as we can, however, we don't know because of the time. So, in general, a point estimator, in point estimation, we need to distinguish between two things: estimator and estimate. Okay, estimator and estimate. And in order to distinguish between them, suppose that I have a parameter theta that I need to estimate. Okay, خلينا نقول عندنا الpopulation. I need to estimate the mean, the average of a population. Okay. Now, if I calculate the average of of the sample that we have, this is called estimate. Estimate is a number. The estimator is the equation that I use to do estimation. يعني خلينا نقول الآن هنا we need to estimate the true average of batteries lifetime, which is x bar. So we have here, we would like to estimate what the true average of batteries lifetime, x bar. We don't have access to all batteries all the time. المصانع عشان يهمهم صنع بطاريات ولا أي شيء in order to check the quality of what we manufacture, what they do is they collect samples. كل مثلا 100 بطارية يطلع بطارية، كل 100 بطارية يطلع بطارية. And they randomly collect the sample and then they check. So they would like from these samples, they collected 3 samples, n equal 3 batteries, and they found that they ran the batteries. They found that the battery life of the first battery was 5 hours. The battery life of the second one was 6.4. The battery life of the third battery was 5.4. Okay? They cannot run all the batteries coming out of the battery, otherwise they will not see anything. صح ولا لا؟ هم يبغوا يستخدموا السامبلز هذه to check what they are manufacturing is up to the standard that they would like. يعني هم يقولوا مثلا البطارية هذه تعيش 6 ساعات. Well, let's see. فالآن, if we would like to estimate the average battery life, we only have 3 samples. So what we can do is we can use a point estimator. نلاحظ R. Estimator is the equation. Theta dash is 1 over n, the summation of x1 to x. This is called the estimator. Estimator means it's the equation that we use to calculate the estimate. واضحة؟ الآن, for these three specific samples, we can calculate estimate. اللي هي الvalue, the exact value. هذه عبارة عن إيش؟ 1 over 3 and summing over, using this equation, 1 over 3 summing from I equal 1 to 3 xi. And we get 5.77. Yes. الفرق بين الاستيميتر والاستيميت. The estimator is the equation we use. The estimate is for specific samples. We run this equation. The estimate is a number. So the estimate here is a number. بينما estimator, a point estimator is a suitable statistics equation operator. واضح؟ واضح؟ So now if I collect another 3 samples, what do you expect? Will you get the same estimate? Most likely no. You will have 3 different batteries, probably 5.7, 5.8, 5.2, whatever. So every time you collect new samples, you will end up with a new estimate. So, however, you are using the same estimator. Estimator is an operator. It's an equation that you use to calculate the estimate every time you collect the samples.
What number of samples you can get more accurate?
Of course. The more samples. طبعا احنا هنتكلم عن accuracy لما نروح على الانترفال estimate. إذا بقى وقت. However, exactly, yes, you are completely right. So the estimator is the calculation is basically the equation that enables me to calculate the estimate once I have the samples. واضح الفرق بين الاثنين؟ This is an operator, this is an equation, a way to calculate. بينما the estimate is the number that results when I collect the samples and I do the calculation. So every time I collect new samples, I expect a new estimate. So a point estimator, theta hat, is what? Is a random variable. Why? Every time I have new samples, I get a new number. المفروض إنه النمبرز هذه كلها قريبة من true value, true average, which we don't know. So theta hat, which is the estimator, is nothing but the true value plus error. So this is the true value. And this is the estimate. So basically the estimator is a random variable by itself. Let's have another example from the big textbook that they gave me. So here we consider 20 observations. 20 observations. So n equal, كم يشبه 20. On dielectric breakdown voltage for pieces of epoxy resin. سيبكم من التفاصيل هذه. So basically, they are getting certain material and they are measuring the dielectric breakdown. The pattern is normal distribution. So they know that it has normal probability plot. So if you plot this, you plot the histogram and you find that it looks like normal. Okay. So we now assume that the distribution of breakdown voltage is normal. Now the point is here, let's try to estimate the average of these numbers of the normal distribution. هذه samples, السامبلز بتعطينا estimate, صح؟ Now let's try different ways, different estimators for the average. نحن الآن تكلمنا عن one simple way, 1 over n summation of the samples, صح؟ There are different ways. You can invent your own way. لكن is it a valid way or not? Valid one or not? Let's see. So here طبعا هنا we are trying to write the estimator and then the estimate. So the estimator is the average. Is basically 1 over n summation. And if we calculate, so if we calculate it for these samples, you will get 555. Sorry, over 20, which is 27.7. This is the straightforward way. We sum all the values, divide by number. Another estimator is x tilde. tilde في الكتاب هذه موجودة هي عبارة عن ايش؟ دي ايش يسموها؟ القيمة الوسطية. دي median. Okay, the median value. القيمة المتوسطة. Basically, we write it from the largest to the minimum to the smallest, and we take the minimum value, the middle point value. طبعا هذا بما أنها even, we have two middle point values, so we take the average, and we get this. لو تلاحظوا هذا الestimator give us a different estimate than the other estimate. قريبين لكن different. Or you can take the smallest, add it to the largest, and divide by 2. This is another way to calculate the average of the data set. Okay? So it's another estimator هنا لو تلاحظوا is the minimum plus the maximum divided by 2. So this is the estimator, the equation. And when we calculate the estimate will give me 27.6. This is a third estimator. A fourth estimator would be, no, I will truncate, يسموه ايش؟ 10% trimmed mean. Means what? Means that I remove the lowest 10% of the data and the highest 10% of the data. أنا أقول إنه هذه pairs ممكن تكون biased، ممكن تكون outliers. So they trim the data. They take مثلا هنا كم عندنا؟ 20. 10% means what? Means I discard 2. So basically I discard the first one, the minimum one, and the largest one. Just to make sure that I don't include outliers. Okay, this is a fourth estimator. The estimator here is the 10% trimmed mean. What does this mean? Means that I remove the top and bottom 10%. Discard the smallest and largest 10%. In this case, if I do the estimate, if I calculate the estimate, it will be 27.8. If the estimator gave me another number. Now, which one is the best? Which one is the closest to the true estimate? It's the true value. We don't know, right? However, there are properties that allow us to distinguish between different estimators. One of them, if the estimator will result in a different number. If I give you 20 new samples, this will give you another number. So the estimator is a random value. So this estimator is a random value. So now one of the ways so basically there are properties of this random variable that should be satisfied. خلينا نتكلم عن واحدة منهم. الآن let's ignore the rest. Let's focus on the first one. اللي هو basically summing and dividing by n. If I give you 20 new samples, ايش تتوقع الرقم يكون؟ تبعتين مختلف. Another 20 new samples, you get another number. So this is basically the output of this estimator is a random variable. However, don't you think that this random variable, its average should be equal to the true average? Yeah. If it's a good estimator, مرات حيعطيني values أكبر مرات حيعطيني values أقل لكن the average if I collect 20 samples after 20 samples after 20 samples حيعطيني خلينا نقول 100 of these 20 samples so I will get 100 different estimates صح ولا لا؟ However their average should be as close as to the true average. Don't you think this is a good estimator? However, if the average of this estimator doesn't reach the true average, do you think it's a good estimator? It means that if I repeat the estimation many times, I will not get at least the true average, close to the true average. Because if the average of the estimator is different than the average the true average. What? Of the normal distribution. The average of the normal distribution. هذا عبارة عن شيء يطلع من المصنع. المصنع يطلع مئات آلاف القطع. You cannot get مئات آلاف القطع of these كلها. Simply this is not practical. زي الباتريز ما تقدر تمسك كل الباتريز تستخدمها. ايش فيها؟ ما في شيء صحيح. So the best you can do is to collect samples and try to calculate. We believe that هنا في البروبلم that the pattern هنا is normal probability. They want to find the mean of that normal distribution. But we don't know the true mean. We have only access to certain samples to do the estimation. Well, so if we collect different samples, every time we'll get a new estimate. So this is a random variable. Its average, if it is a good estimator, should give me the true mean. واضحة الفكرة؟
مو شرط انه يكون ضد السلاح.
يعني هذه واحدة من properties of a good estimator. Okay, this is one of the properties of a good estimator. لأنه if the average of these many samples will not give me the true average, this is not a good estimator. So this is one of the properties. We'll talk about different properties in a minute. We don't know. هنشوف كيف هنسويها. Exactly, we don't know. هنشوف الآن how do we find out whether we get the true average. يعني at least in probability. So the first, خلينا بس قبل نمشي لهذه, the first property of a good estimator is called unbiased estimator. Unbiased means that unbiased or point estimator, theta hat of theta implies that the expected value of theta hat equals theta. Theta hat is the estimator. Theta is the true value. So theta hat here is the estimator of theta. Theta is the true parameter that we would like to estimate. واضحة شباب الفرق؟ So if this theta hat, احنا قلنا اقتنعنا انه theta hat is a random variable, صح؟ If this random variable, its average, is equal to the true estimator, then this is what we call unbiased estimator. Okay? Before I go into this, let's find out how we calculate this. Now. Yeah, unbiased estimator is a property. Here we have four different estimators. We can discuss one at a time. Let's see the first one. The first one عبارة عن ايش؟ theta hat عبارة عن 1 over n summation I equal 1 to n xi, right? So, however, xi are coming from are basically samples. Every xi is by itself is a random. Every one of them, every time we collect samples, these are random variables by themselves. So now, what is the expected value of theta hat? It's the expected value of whatever n sin. صح؟ زي ما تعلمنا في probability. 1 over n summation I equal 1 to n x. صح؟ And we know that the expectation operator is linear. So we can exchange the expectation with the summation. So this is 1 over n. So the summation. Right? I equal 1 to n of the expected value of xi. But what is the expected value of xi? This is the true value. This is by definition